In this video, we are going to focus on similarity in triangles. Two triangles are similar if corresponding angles are equal and corresponding sides are in proportion, the same ratio. The similarity statement for two similar triangles, using these examples here for triangle ABC and triangle DEF, is triangle ABC is similar to triangle DEF. This symbol means is similar to. So if we look at our triangle here, we've got triangle A, B and C, which is featured here to begin with, and we go alphabetical order. And then we look at the second triangle and we're matching up these angles, so we must go in the same direction. So triangle DEF, because it goes in the same direction as A, B and C, and where you start, the same angle should be there. The next angle, the second angle in the middle, should be identical, as well as the third, and you can see the markings show that. The test for similarity in triangles is that all angles are equal. So if we go through these here, this little symbol here means angle, and this is just again equal to. So it's not similar to, this is just showing that the angles match for angle, angle, angle rule. So angle BAC, so BAC is equal to angle EDF, EDF. So it's going in the same direction. So no matter what you say, the angle that you're identifying is the middle letter. So the dot and the dot, A and the D, are the actual angle that we're looking at in this case. This is angle ABC is equal to angle DEF. So angle ABC is equal to DEF. The second letter indicates that this is the angle that we're looking at. And finally, angle ACB is equal to angle DFE. So we go ACB, so it's this angle we're focusing on. Therefore, we go DFE, identical angle. So each middle letter is the actual angle. It is important to note when using the AAA test, only two corresponding angles have to be checked. Since the sum of the interior angles in any triangle is a constant number at 180 degrees, the third pair of corresponding angles will automatically be equal, provided that the first two pairs match exactly. They are not identical triangles in size. This would make them congruent triangles. So these triangles are identified as similar based on their angles, not by their size. We are now going to look at some practical applications. Sometimes you get two triangles joined together with one sitting inside the other. And you can see I've drawn one here. You've got a large triangle, A, B and C, and a smaller triangle of A, D, E. The similarity statements for this particular triangle will match up the angles. So I've actually color-coded the green and the blue just to show you where they fit into these similarity statements. So we look at this blue one here, it says angle ADE, so angle ADE is equal to angle ABC, ABC. So it's actually in the same position. B has a dot and D has a dot. That's the angle of D and angle of B. They are corresponding angles. So this is how you would write it here. The angle ADE is equal to angle ABC, and it's a corresponding angle. The same thing goes for the second angle that matches up. They are corresponding angles as well. So angle AED, AED, which is this little one here, is equal to angle ACB, ACB. So these angles here match up as well. The thing with the top one here, this is actually owned by both, so it's common to both triangles. So angle DAE, DAE is equal to angle BAC, BAC. So they both share this apex angle at the top, which is why it's common to both triangles. Because all the angles match up, you write the therefore statement. Therefore, triangle ADE is similar to triangle ABC by AAA, which means angle, angle, angle. So all letters are in matching order, And similarity statements must be written as well as the therefore statement proving similarity by A. Let's take a look at this second example here. We have two triangles joined at the apex at point C here, and we're going to create three similarity statements based on the matching angles, and then we write the therefore statement at the end showing that it is similar to each other based on the angle rule. Let's look at the first one. It says angle ACB is equal to angle ECD. So we start at A and we start at E, and they're both dots, which is good because we've got to match these up. We then move into angle C, and I know that angle C is exactly what we're looking at because that is the middle letter, so they commonly share this one here. And then they move off to B and D, which is the arc. So we're going dot cross arc. That is the correct order, and they are vertically opposite angles because you must make a statement based on the type of angle. These are vertically opposite at point C. The second one here is angle CAB. So I'm starting at C, and so is the other one because we must start at the same matching angle. So CAB, so cross dot arc. We do the same thing at the bottom. Cross dot arc CED. So the letters must match those markings to prove that those angles are equal, and we go in the same order, the same direction. They are alternate angles because that is the Z shape. So we know that angle E and A are equal because this is a parallel line indicated by these arrows. So this is our Z shape. And remember, this is a parallel line. This is the line that cuts through, the transversal line. And on the opposite side of the transversal line, we have the alternate angles, which is why it's written here. And the last one is the same situation, alternate angles. We've got angle ABC dot arc cross is equal to angle EDC dot angle cross, okay, or dot arc cross, I should say. So they are the matching markings that proves that we are going in the right direction, and all of our markings line up. We know that the angles we're talking about are the middle letter, and because it all matches up, we've got our rules here. We can make the similarity therefore statement. Therefore, triangle ABC is similar to triangle EDC by AAA, which means angle, angle, angle. And our final example here, we have a right angled triangle with one smaller one sitting inside the larger one. We're going to write the three similarity statements to match the angles up, give a reason, and then do the therefore statement at the end, proving that they are similar triangles because of the AAA, the angle, angle, angle rule. So we have angle ABE. Angle ABE is equal to angle CDE. The middle angle here of B and D is the right angle. We are going in the same direction. So all of those letters are matched up, and the rule there would be both 90 degrees. The second one, we are angle BAE. So BAE, it's this little arc here. So that's equal to angle DCE. So we go 90 degree, the arc, and they both share this dot here. This is a common angle. Now, this is the F shape, the corresponding angles. So it's like saying that the armpits of the F. So if you look here, you can see that we have a very wonky looking F, and under the armpits of the F is the angle that we're looking at. So that's corresponding angles. And finally, we have angle AEB. So AEB, the dot being the common one here, therefore it will also be in the center of the next angle, which is CED. So AEB, CED. I'm just going to draw this for you. I'm going to show you that we're going in the same direction. So angle AEB, and we've got angle CED. So we must go in exactly the same direction, and that's why you'll find that the middle letter with a commonly shared angle will be the same. And that's common to both triangles. So this is a similar triangle, and therefore we say, therefore, triangle ABC is similar to triangle CDE by AAA, which means angle, angle, angle.